In this video, we're going to be doing algebraic limits, okay? And I call it the law of substitution. So what do we mean by algebraic limits? Well, in the algebraic limits, it's always going to be the limit as x approaches some number here, but then here I'm going to give you an algebraic, and a function, some kind of a function. It's not going to be f of x. It's going to be something like 3x plus 5, square root of x, and so forth. All right. So that's what they mean by algebraic limits. Now, what's the objective? It's going to have multiple objectives in this little video. The first one is evaluate an algebraic limit by substituting, which is the law. All right. Determine when an algebraic limit fails to exist. Differentiate between 0 over 0, 0 over a number, and a number over 0. Now these numbers here, 0 is considered a number, right? But in this case, we're not going to consider 0 to be in that scenario. All right. Determine when a function has a hole in its graph. Determine when a function has an asymptote in this graph. And these are prerequisites from previous classes, but I'm still plugging it in just to refresh your memory. And finally, evaluate 3 algebraic limits by either simplifying, rationalizing, or factoring. So let's go ahead and start off with the very first one. The first rule of limits is to always substitute. All right. Now, if you substitute, there's 3 possible scenarios. The first one is if we get a number. If we get a number that is not 0 over a number, all right, or 0 over 0, we are completely done. Okay, that's it. Now, some of you might get confused with this part right here. So let's pretend that I substitute and I get 0 over 7. 0 over 7 is 0. All right. If I get 0 over 10, 0 over 10 is 0. Now, if I reverse them, then I would be doing the one on the number scenario number 3. I would be getting 7 over 0. That does not exist. Or if I had done 10 over 0, that does not exist. These are what we call asymptotes. We're going to have asymptotes at those locations. Now, if we substitute and we get 0 over 0, we are going to get holes in our graph. Holes. So these are the 3 scenarios that you're always going to do when you substitute. Remember, the law of limits. If you ever see a limit, substitute it. If you get a number, boom, you're done. All right. Now, if you get 0 over 0, I'm going to tell you what you can do if you get 0 over 0. And then I'm going to show you an example of what you're going to do when you get asymptotes. So here we go. Let's start off with the very basic one. Find the examples of these 4 limits. Mr. Quintana, what did I say that you're going to do on limits? You're just going to substitute. So I'm going to go 5 times 3 plus 2. That's going to give me 15 plus 2, 17. And I'm done. All right. Now the next one, I'm going to substitute and I'm going to end up with 2 square root of 7 times 7. That's going to be 2 times the square root of 49, which is going to be 2 times 7, which is 14. So that means that my limit and my function is 14. I'm done. The next one says find me the limit of the natural log of e plus 4. And you're supposed to know that the natural log base e of e is 1. So we're going to say 1 plus 4 is 5. And I'm done. And finally, the last one, when I substitute, I'm going to substitute and I'm going to get 3 minus 3 over 3 plus 5. That's going to give me 0 over 8. And what did I just finish saying in the previous slide? That 0 divided by any number not 0 is going to be 0. And I'm finished. Okay? So let's go ahead and look at the next scenario. Now, in the second scenario, we always substitute. If we substitute and we get 0 over 0. Now, 0 over 0 means that there's a hole in my graph. That is going to be a key for us. That's going to tell us that we can do one of 3 things. We have to get rid of that hole. All right. So how do we get rid of that hole? There's going to be some scenarios here. We can factor and then cancel the hole. We can rationalize it and get rid of the hole. Or we can remove the fraction within a fraction and then get rid of the hole. So some of you might say, sir, I'm completely lost. All right. So what you need to do is you need to see a scenario for each one. All right. So let's go ahead and look at some scenarios here. The very first one, it says, I'm going to take the negative 4 and I'm going to plug it in. I'm going to get negative 4 squared minus 16 over negative 4 plus 4. That's going to give me 16 minus 16 over 0. That's 0 over 0. And this is going to be my clue. That's going to tell me it's a whole. And every time we get a whole, we're going to be able to simplify it. All right. So in this case, what we're going to do is we're going to factor. How do you factor x squared minus 16? Well, you can factor it as x plus 4 and x minus 4. And on the bottom, you're going to have x plus 4. Wait a minute. Do you see something unique here? Yes, I'm going to notice, Mr. Quintana, that the x plus 4 is down here at the bottom and it's up here at the top. So that's going to reduce to a 1. And I'm left with the limit as x approaches negative 4 of x minus 4. And now we go back to the law of limits, which is substitute. Negative 4 minus 4, negative 8. So that means that my function has a whole at negative 4 comma negative 8. So there's a whole at negative 4, negative 8. So my function is approaching negative 8. Remember that the definition of a limit is the y-coordinate that the function is approaching. All right, now we're going to look at a more complicated scenario here. I'm going to take and I'm going to substitute, and when I substitute my 2, I'm going to get 2 minus 2 over the square root of 2 minus the square root of 2, and that's going to give me 0 over 0. Now this is one of the ones that students hate the most because they forget to rationalize. So I'm going to go ahead and erase all of this because you have to recall from college algebra that I have to multiply something to this so I can get rid of those radicals on the bottom. So I'm going to be multiplying it by its conjugate. Ooh, that sounds like a word that some might click for some of you, conjugate. Now the conjugate, if it's a minus there, then I'm going to put a plus there. Now remember that in mathematics that you can multiply by 1. 1 times 7 is 7, 1 times 10 is 10, 1 times 12 is 12, 1 times anything is anything. So if I have to have this on the bottom and if I put 1 on top, what is the square root of 2 plus the square root of x divided by square root of 2 plus the square root of x? That's 1. And 1 times anything is anything. So now when I have this, the bottom, you only worry about the conjugates. Don't multiply out the top. Leave the top alone, all right? So I'm going to keep the limit here in the front as x approaches 2. And on top, I'm going to leave it. It's going to look ugly, but you got to trust me on this, all right? So I'm going to leave the conjugate there. And on the bottom, when I multiply conjugates, so I'm going to come up here and I'm going to say the square root of 2 minus the square root of x times the square root of 2 plus the square root of x. I love conjugates because this times this is going to give me the square root of 4. This times this is going to give me negative square root of x squared. And then when I multiply this and this, they're actually going to cancel each other out. But I'm going to put it on there. I'm going to have plus the square root of 2x, and then I'm going to have minus the square root of 2x. And right here, Mr. Quintana, this and this are going to cancel. So I'm going to be left with the square root of 4, which is really 2. And here, the square root of x squared is just going to be x. So I'm really going to be left with 2 minus x. So I'm going to have 2 minus x on the bottom. And you say, hey, sir, they're not the same. This guy and this guy are not the same. Well, in mathematics, you can almost say that they are the same, but they're not the same. Look at what I'm going to do. I'm going to factor out a negative 1. So let's go ahead and take out a negative 1 from the top. So when I take out a negative 1, I'm going to be left with negative x plus 2. All right, and I'm going to leave that conjugate up there. And on the bottom, I'm going to have 2 minus x. And again, you're going to say, sir, it doesn't look the same. Well, now, by one of the properties in mathematics, I can rearrange this, the commutative property. I can have 2 minus x, and then multiply it by its conjugate, square root of 2 plus the square root of x, over 2 minus x. Do you see it now? Do you see how that whole is going to disappear? This guy and this guy reduces to a 1. And 1 times anything is anything. So now that I have that, now I bring back my limit here in the front, the limit as x approaches 2. So when I plug in my 2, I'm going to have negative 1 square root of 2 plus the square root of 2. And that's going to give me negative 1 times 2 square root of 2. And that's going to give me negative 2 square root of 2. And this is the answer for this problem. All right? So let's go ahead and look at the third type of scenario. Remember the first scenario, I factored to get rid of the whole. The second scenario, I rationalized to get rid of the whole. Now let's look at the third scenario. Now I have a fraction within a fraction. So I'm going to substitute right here. When I substitute, I'm going to get 1/3 minus 1/3 over 3 minus 3. That's going to give me 0 over 0. And this tells me that there's a whole. Now in the last scenario, you're going to multiply by the mini denominators. That's the way I tell my students what to do, how to do this problem. Now x minus 3 here, he's your big denominator. The 3 is a mini denominator, the x is the mini denominator. So I'm going to multiply everything by 3 and the x. So what you multiply to the top, you have to multiply to the bottom, because 3x divided by 3x is 1, and 1 times anything is anything. So that's acceptable. So when I distribute now, when I distribute 3x times this, I'm going to have 3x over 3 minus 3x over x over, now you're going to have this urge to multiply it out. Don't do that. All right, let's not forget that limit here in the front as x approaches 3. So now what's going to happen on the first mini fraction? The 3 is reduced. What happens in my second one? The x is reduced. So I'm going to be left with the limit as x approaches 3, and I'm going to be left on top. I'm going to have x minus 3, and on the bottom I'm going to have x minus 3 times 3x. Oh, do you see it? Do you see how that x minus 3 reduced? Well, x minus 3 divided by x minus 3 is just a big fat 1. But in reality, I'm getting rid of the whole. So now that I have this, now I substitute. I take my 3 and I substitute it. So I'm going to have 1 over 3 times 3, and that's going to give me 1 over 9. And this is my limit. All right? Now, let me go ahead and refresh. What are the 3 things that happen whenever you get a whole? Whenever you get a whole, 3 scenarios are going to exist. Number 1, you're going to be able to factor it, cancel the whole, then substitute. Or, when you get 0 over 0, you might have to rationalize, multiplying by its conjugate, and then get rid of the whole, and then substitute. The third scenario is, if you substitute get 0 over 0, you might have a whole, but here you have fractions within a fraction, so you multiply by the many denominators, get rid of the whole, then substitute. All right? Now, the last and final scenario is what happens when I substitute. Remember the law of limits. We substitute. What happens if I substitute and I get a number that's not 0 over 0? Something like 7 over 0, or 12 over 0, or negative 5 over 0. All of these are going to be asymptotes. Okay? Now, as soon as you have this, you can say that the limit does not exist, and you're done. You're always going to be right. Okay? So, now, there's another answer that's acceptable, right? And that would be if you know there's an asymptote. So let me go ahead and give you a scenario here. At 3, there's an asymptote. Okay? And I have a function that's going to go up like this, and on the right side is going to go up like this. So what's my limit as x approaches 3? You're going to say there is no limit, because they're not approaching a y coordinate. They're going to infinity. It's never going to stop. It's never going to approach a y coordinate. However, mathematicians said, wait a minute. If the left-hand limit is going up forever and ever, that means that we're going to say that the limit as x approaches 3 from the left of f of x is going to be infinity. The limit of f of x as x approaches 3 from the right is also going to be infinity. Now this guy and this guy are the same guy. So we can say that the limit is infinity. So that's another acceptable answer. And that might be a better answer, because it's going to tell you something about the graph rather than does not exist. Now, the question is, how do you know that? How do you know? Well, I need for you to know that there's going to be 4 scenarios. Okay? The first scenario we already covered. They both go up. Or one goes up, one goes down. Or they both go down. Or it goes down and then this one goes up. Okay, and here's my asymptote, and here's my asymptote, and here's my asymptote, and here's my asymptote. So there, I did 4 pictures here at 0, and if you notice, this one goes up on the right side but goes down. So this one, the only acceptable answer is going to be does not exist. On this one, the only acceptable answer is does not exist. But on the two on the bottom ones though, those are special though. You can say that the limit does not exist for both of them. But this one has a better answer. You can say that the limit is infinity. And for this one, you can say that the limit at 0 is going to be negative infinity. Okay? So let's go ahead and look at it. All right, now, how do I know this? I'm going to substitute my 3. Remember the law of limits? We do the substitution, and I'm going to get 1 over 0. And this is going to tell me that it's asymptotic. Okay? So there's an asymptote at x equals 3. All right? Now, if I get 0 over 0, there's a hole. If I get a number that is not 0 over 0, then there's an asymptote. So now that I know that there's an asymptote, remember we got those 4 possibilities. So I have to go to the previous video on one-sided limits. So what I'm going to do is I'm going to find the limit as x approaches 3 from the left of 1 over x minus 3. I'm going to do the limit as x approaches 3 from the right of 1 over x minus 3. Now, on the previous video, you were taught that, hey, you're going to insert a number close to 3 but on the left side of 3. So I'm going to draw a number line, and here's my 3. So what is a number to the left of 3 but very close to 3? So I'm going to try 2.9. So I'm going to say 2.999 minus 3. Now I don't care about the value, I only care about the sign. So on top I'm going to have positive, and on the bottom I'm going to have a negative. Positive divided by negative, that means it's going to be negative. And my value, of course, is going to be infinity. So now I know that the left side of my graph is going to go to negative infinity. Now I have to pick a number to the right side of 3. So I'm going to pick a number close to 3 but on the right side. So I'm going to pick the number 3.001 minus 3. So that's going to give me a positive on top again. And on the bottom, 3.001 minus 3 is going to be positive. So that's going to give me positive infinity. So Mr. Quintana, the left limit and the right limit are not the same. So the only acceptable answer for this is does not exist. And that concludes the video.